Okay, so we're going to go ahead and get started, and we're going to look at 3.1. We'll look at question number 2 first. 3.1, we're looking at ordered pairs. So some of these are plot your ordered pairs. Some of these are complete tables. This one, we need to go ahead and fill in the missing ordered pair. So what we have is we have one part of the ordered pair already. So for question number 2, what we have is we have 4x plus y equals a minus 29. So that's what we've got. Now we have a partially completed ordered pair, which is blank, comma, minus 29. And that 29, well, that is your y value. The unknown part is the x value. And what we need to do is we need to plug in the y part and find the x. You're always going to have one variable, and we solve and we get the other variable. So in this case, we have that y is negative 29. So I'm going to plug that in. So 4x, y is a minus 29, so that gets plugged in there. And that equals a minus 29. We're going to move our 29 over with addition. And now we get 4x equals 0. Okay. And how do we finish out this one? We divide by our 4. And 0 divided by any number is still 0. So 0 divided by 4 is still 0. So what does my ordered pair look like? Well, we've got the x component. We need to go ahead now and get the y component we found and put our ordered pair back together. Okay, so we've got our x component. We're going to rewrite that as 0. That's my x component. And my y component there is a minus 29. So we plugged in one value, and we got the other value. Question 5, we need to complete this table, and then use this table to graph the line. So we have this equation on 5. We have this equation, x minus y equals 1. And we've got a table of values. And we've got all of our y values listed. So we have 0, 2, negative 2, and 4. And what we need to find is we need to find the corresponding x value. So we're going to be filling in the missing blanks over here. So we have our y values already listed. We need to find our x value. So each one of these we're going to plug in, and we're going to see what we get over here, and that's going to make our ordered pairs. So we're going to start with y equals 0. So if I plug in y equals 0, then I get x minus 0 equals 1. And 0 goes away, so that gives you x equals now 1. So that's going to be our first ordered pair, which is 1, 0. Okay, and that is actually your X-intercept there. That's where it crosses the x-axis. So what about our next one? The next one we're going to plug in 2. So we're going to plug in y equals 2. And if I plug in y equals 2, I get x minus 2 equals 1. We're going to add our 2 to each side. And that leaves me with 3. So that's our new ordered pair, 3, 2. Now when we plug in that negative 2, we've got to be careful because we have to make sure we watch out for that double negative. So for the next one, we've got a -2. And this is already negative up here, so that's going to make it a double negative. Sorry, y. Sorry about that. That's y, not x. Okay, so we're going to plug in y equals -2. Yep, so we wrote down the wrong one. And that negative is there. Another negative, that makes it a double negative. So now we have x minus a -2 equals 1. We know that this double negative here, well, that's going to make that then positive. And now we've got x plus 2 equals 1. Subtract off your 2. And so x now equals a -1. So move things around and watch out for that double negative. The next one is 4. So the next one is y equals 4. So we'll plug in 4. And that's going to be x minus 4 equals 1. Add that 4 over. So that leaves me now with x equals 5. So we've got our ordered pairs now. We've got 1, 0. We've got 3, 2. We have -1, -2. And we have 5, 4. So that is what we've got so far. Now we need to graph this line. So we're going to begin by plotting our points that we've got. Now they should make a line. If they do not make a straight line, you made a mistake. So when I go to graph these, if they make some kind of a curve, you made a mistake. These have to be straight lines. Okay? That's how you know if one point doesn't fit on a ruler, you made a mistake. Let's go ahead and plot these points here. Get a better marker. So we're going to plot our points. Make sure you don't get the x and the y mixed up. Remember, x is first, y is the second part. So 1, 0, that's over 1, and at 0. Next, we've got 3, 2, so that's over 3, and up 2. Then we've got -1, -2, which is right here. And then we've got 5, 4. So there's 3, 4, 5, and then up 2, 3, 4. So that's going to be approximately right there at 5, 4. Now, we know that we did it correctly because when I try to connect them together, it makes a line, doesn't it? Okay. That one's off a bit because my graph is off. You've got a grid you can actually use, but they should look like this. They should make a straight line just like that. As long as they make a straight line just like that, you know then that you did the question correctly. Three, 2 is talking about intercepts and more of graphing these lines. So for 3, 2, we're going to begin with question number 3. And so these are going to be graphing these lines. And the easiest way to graph them is just find the intercepts. There's other ways that we'll learn about today, about how to graph them just on their equation without getting points. But for right now, in 3, 2, you're going to want to go ahead and find your intercepts and use those 2 points to graph your line. So we're in 3, 2, and we're going to begin with question 3. And question 3 is y plus 5 equals 0. Now, when I look at this question, I need to kind of think in my mind what the graph is going to look like. Well, first off, I only have one variable. So the only variable I have right now is the y. If you only have a y variable, then what is the graph going to look like? If you just have the y, it's horizontal. If you just have the x, it's vertical. If you have the x and the y both, what do you get? Diagonal. So we know this is going to now be a horizontal line. It's set to 0. To graph this one, we need to figure out what my horizontal line is going to be at, where it's going to be at. So we're going to move that 5 over. That way we can get the y by itself. And now we're left with y equals a -5. Now we know that we can graph this line without picking points because what do we know? We know this is a y line, and since it's a y only line, that means it's a horizontal line. And where is it a horizontal line at? -5. So we're going to go down 5 units on our y-axis. Okay, and there's -5. We're just going to draw a straight line across, a horizontal line across. There is your graph. So on this one, we didn't have to find the intercepts, but right here, that would actually be your y-intercept, because that's where it crosses the y-axis. And as an ordered pair, that would be 0, -5. We don't have to have it, but we're already here. We might as well label it. So that 0, -5, that is going to be your y-intercept. We don't have an x-intercept because it never crosses the x-axis. Graphing is very visual, and I think you really need to understand the pictures rather than just plugging numbers into formulas. The intercepts are where they cross the axis. Question 5 is next to look at. And question 5, we've got 9x plus y equals 0. So when we look at question 5, automatically what do we know? Well, automatically we know that this is going to be some kind of diagonal line. We've got the x and we've got the y both. So let's try to find our intercepts. And let's work with our intercept table. So the intercept table, we just plug in our zeros. We see what comes out. So we're going to plug in x equals 0. If I plug in x equals 0, then that gives you 9 times 0, which is 0, and that gives you y equals 0. What about the next one? Well, same concept. If I plug in y equals 0, that gives you 9x plus 0 equals 0, which is 9x equals 0, and then x equals then 0. So we know our intercepts. And what are our intercepts? Well, in this case, both intercepts are 0, 0. Now, when we go to graph a line, what do we have to have? At the very basics of graphing a line, we have to have 2 different points. These came out to be the double 0. So we need to come up with another point. So we have to have 2 different points. We can't just graph it with 1. We have to have a minimum of 2. So if we don't know the other point, if they're the same, because it came out to be double 0, then we pick a value for x. And the easiest value to plug in is normally going to be 1. So I'm going to plug in 1. Okay, so now we're going to plug in x equals 1. You can plug in any value that you want for the x and find the y value. So I chose 1 because 1's easy to work with. So we're going to pick x equals 1. And that gives you 9 times 1. plus y equals 0. So that's 9 plus y then equals 0. Okay. And we'll move the 9 over. And what do we now get? We get y equals a negative 9. So we've got the first point, which is at 0, 0, and our second point, which is 1, negative 9. So the second point is 1, negative 9. Okay, now we can graph this because we have two unique points. So we got the double 0. So that meant we had to have another point. So I just picked 1 for the x, plugged it in, got the corresponding y value. So now we have two unique points. We're going to start at the origin at 0, 0, because that's our first point. And then we have 1, negative 9. So that's over 1. And then down 1, 2, 3, 4, 5, 6, 7, 8, 9. So clear down here. 1 comma negative 9. And now we can connect them together. And we've got our line. Other marker here. So we're going to connect these together. We're going to make our line. So whenever you get the double 0, you've got to have another point. So what I do is you can use any value that you want. I usually pick x equals 1 because it's easy. So I pick x equals 1. That gave me then 1, negative 9. And I use that 1, negative 9 then to plot it with the double 0 to make my graph. And that was question number 5. Question number 8. Very similar again. Okay, so question number 8 is also going to have the double 0. So question number 8 is y equals 8x. Now let's start with our intercept table. So we're going to go ahead and plug in our zeros. And we're going to see again what we get out. I plug in x equals 0. And I get y equals 8 times 0, which is then 0. And once you get one of them to be double 0, the other one is also going to be double 0. So I can also plug in that y, but it's going to also give you 0 out. So if I plug in y equals 0, it gives you 0 equals 8x, which is then x equals 0 as well. So both intercepts now are 0, 0. Is everyone okay with that? Now, can we graph this yet? No. Why not? We need two distinct points. Okay? We only have one. So we have to come up with another one somehow. I always like to plug in an easy value to work with. So I'm going to choose x equals 1. You could have chosen x equals 2 or negative 1 or any number that you want. But 1 is easy. Okay? 1 makes it easy because 1 is not difficult to work with. So now let's plug in our 1. So we've got x equals 1. So y equals 8 times 1, which is then y equals 8. And that is my second unique point, which is 1, 8. So that second point is 1, 8. We've got the double 0. And then we have the second point, 1, 8. So that's over 1. And up 1, 2, 3, 4, 5, 6, 7, 8. And we can now connect these together. And there we go. There's our line. So we've graphed it, and we have our line drawn. And I think I also picked question number 6, so I might have forgot to go back and do that one. So let's go ahead and look at 6. I picked 6 as well, just because it's written differently. So I forgot to do 6, so we're going to go back and look at question number 6 here. Okay, so let's try to find our intercepts again. Now this one should give us 2 intercepts. We should get 2 different values. And I picked this one just because it's written in a different order. Normally the x is not on the left by itself. It's normally the y. But let's go ahead now and try to graph this line. So we're going to find our intercepts. So if I plug in x equals 0, that gives you negative 6 times 0 equals y plus 7. And negative 6 times 0, that goes away. That's still 0. Move that 7 over. And now what do we get? Y equals negative 7. So that's not difficult at all on that point. When we do the y equals 0, we may end up with a fraction. And that's okay, because we can still graph the fraction. We just kind of guess as to where it's at when we go to graph these. So now we've got x equals 0. We plug that in. We got negative 7. Now we're going to plug in the other one. We're going to plug in y equals 0. When I plug in y equals 0, that y component goes away. So I get minus 6x equals 7. And what do we do? Well, we just divide. And that gives us x equals now negative 7/6. Okay, so now do we have 2 distinct points? Yes. Okay, we need to make sure we have 2 different points. And it's okay to have a fraction. They're not always going to come out to be whole numbers. Most of the time they will be. But it's okay to have a fraction. When we go to graph the fraction, we just kind of guess as to where it's at, what it's close to, the whole number that it's closest to. So now we have our 2 points. Let's go ahead and label them, what they are. Okay, this one right here is 0, negative 7. And so it has a y part. So this is going to be your y-intercept. What about the other one? The other one is negative 7/6, comma 0. And that is going to be your x-intercept. Okay. We have an x-intercept, and we have our y-intercept there. Now, when we go to graph it, we need to figure out what that negative 7/6 is as a decimal. So if I look at negative 7/6 as a decimal, all we need is one place. What's negative 7/6? Well, let's run it through our calculator and see. So we've got negative 7/6. And I know it might be hard to read there, but that's going to come out to be a negative 1.16. Okay. Well, if you round negative 1.2, approximately. And so what do we know about that one? Well, that's going to be close to negative 1, isn't it? Okay. Because minus 1.2 is going to be close to negative 1. When we go to graph these, it doesn't have to be an exact perfect graph. We just have to get an idea of where it's at. When we graph things, this is just working through these so we can visually see what's happening. They're not going to be perfect graphs. If we wanted a perfect graph, we would use a computer, and we would have that computer plot these exact points, and it would give us a perfect graph. We're just sketching these graphs. So we approximate that fraction with about a -1 because that's pretty close to where it's at. So when I go to graph this, our first point is at 0, -7. So that's going to be right about there at 0, -7. Our second point, this is about -1. So our second point is going to be at about -1, comma 0. So I'll call that -1. Ours is just a little bit past that, not by much at all. And that's our second point, which is -7/6, comma 0. Now we have our two distinct points, and it's real close to that -1 because there's -1, and here's -2, so I just kind of picked it close to it. We can now connect these together, and we get our graph. Okay, so there's our graph right there. So when we go to graph a fraction, kind of guess as to where it's at. They're not going to be perfect graphs. We're just trying to get a visual interpretation of what's happening. Okay, we've got a few more to look at. Question 10 is the next one that we asked about. Okay, so question 10 here in 3-2. We're going to find our intercept. So for question 10, we have -2x minus 2y equals 10. We're not going to have to graph this one. Okay, so it says find the intercepts for the graph of the equation. So all we have to do is find our intercepts. Okay, and we've done this before. When we want to find our intercepts, what do? We create our table. And this is going to be our intercept table with the zeros in it. So this is our intercept table here. Let's go ahead now and plug in our 0 for the x. Calculate it out. Plug in the 0 for the y. Calculate it out. And get our intercepts. So we're going to plug in x equals 0. And that just plugs in the x part with a 0. That goes straight away. So now we're left with -2y equals 10. We'll divide by our -2. And now we have y equals -5. Next one, y equals 0. That's going to give us now our x-intercept. So plug in your y equals 0, and we get -2x minus 2 times 0 equals our 10. That part goes away again. So -2x equals 10. Divide by our -2, and what do we get x equals now? X should equal that -5. Now we need to write out our ordered pairs, and we're going to have 2 of them. Do not try to put them together. A lot of times I see students do this. They say, oh, well, this will be my answer, -5, -5. No. This is not the answer. Okay? We do not do that. Do not combine them together. They have to be separated and labeled. So do not do this. Okay, don't put them together. Our answer would be what? Our answers would be 0, -5, and -5, comma 0. This one is the y-intercept. How do I know that it's the y-intercept? I know that it's the y-intercept because x is 0. And I have a y value. That's so you remember. It has a y value, so it's your y-intercept. The next one is the x-intercept. And how do I know that it's the x-intercept? Because I have an x value. Right? That's the way I remember. Y has a Y value. X-intercept has an X value. It's all about just remembering what is what, and never, ever, ever do this. That's the completely incorrect way of doing that, because that's one point and it's not even a point on the graph. We need those two intercepts there. But a commonly made mistake is students do this. I see it happen all the time. They work it all out, they get here, and you'd get half credit if you did this because it has to be split out into the two. So do not try to give me this. It should be split out into those two. $12 is very similar, but 12 again is going to give us the double zeros. So for 12, we have minus 4x plus 3y equals 0. So we're going to make our intercept table again. So nothing new. This one, though, is going to give us the double zero. We don't have to add on any extra points because we're not asked to graph this one. All we're wanting to do is just find the intercepts of the graph. So we've got our table set up. Let's plug in x equals 0. So if I plug in x equals 0, that part goes away, and we get 3y equals 0, which is then y equals 0. Now, if one of them is double 0, then the other one has to be double 0. I knew, without even making a table, that this one would have the double zeros. Why? Because it equals 0. So remember, if it equals 0, it's going to have the double 0 for the intercept. You can work it out, but if your equation equals 0, you automatically know that you're going to have the double zeros. And if you get one as 0, then the other one must also be 0. So it asks for intercepts. So what would the intercepts be? Well, the X-intercept is going to be 0, 0, and the Y-intercept is the same thing. The Y-intercept is also 0, 0. So you have them, but in this case they are the same. So you have an X-intercept and you also have a Y-intercept. We don't have to add on another point because we're not asked to graph this one. So we don't need any extra or additional points. So that was question 12. One more out of this section, and then we'll look at 3.3, which is the slope. So 14 is the last question out of this section. And I picked this one just because of the fractions. So we need to go ahead and graph this line. If you read the directions, it says complete the ordered pairs and plot the points to draw the line through them. So we've got x equals 3y minus 5. And we need to fill in the blanks. So we've got blank comma 0. We've got 0 comma blank. And we've got blank comma 1/3. Now, I will give you kind of a hint on this one. When we graph a line, how many different points do we need? We need a minimum of 2. Okay? So I've got 3. I'm going to go ahead and get this one with the fraction, but I'm not necessarily going to have to plot that point because we only really need 2. You can plot the fraction, right? But if you got 2 points, that's all you need. We're going to go ahead and find the value, but I'm not going to plot it because it's hard to plot that 1/3, and we've got 2 other points that we can use efficiently. So you only need 2. Minimum of 2. You can have more, but you don't have to. So we're not even going to plot this. We're going to fill it in, and we're going to calculate it out, but we're not going to plot that one. So let's start with this one here. Remember, this is our x. So our first one, we're going to plug in x equals 0. And that's then 0 equals 3y minus 5. So that's, oh wait, yeah, this one. Sorry, this one will be 0. This is the y value. Sorry about that. We'll just do this one first. My mistake here. So we're going to go ahead and plug in x equals 0 on this one. We'll do this one first, then we'll do that one. So we're going to plug in the x equals 0. Okay, so I did that. I'm going to move that 5 over. And now we've got 5 equals 3y. We're going to divide by our 3. And that gives us now y equals 5/3. So that one's going to go over here as 5/3. And that's okay. We can plot that fraction. 5/3 is a lot easier to plot than 1/3 because 1/3 is so small. But 5/3 we can definitely do. The next one, we're going to plug in y equals 0. And if I plug in y equals 0, then I get x equals 3 times 0 minus 5. That's gone. So that one is simply x equals now negative 5. And we need one more. Or we don't have to have one more, but we need to find this last one here. We're going to use that 1/3, and that's your y value. So we're going to plug in y equals 1/3. And this one is going to be nice because that 1/3 and that 3, well, they cancel out and leave you with a 1. Right? Because 3 times 1/3, well, those can cancel out, and that leaves you with 1, because these are the same. And that leaves you with 1 minus 5, and then that comes out to be a minus 4. So that's what we've got to work with here. Now, when we go to graph these, we've got to graph at least 2 of them. We can graph all 3, but it's going to be kind of hard to plot that 1/3. Because 1/3 is so small, it's so close to 0. So I'm just going to plot the first 2 points, and then those 2 points are going to be enough. When we graph lines, all you have to have is 2 points, so you can connect them together with a ruler or a straight edge. So let's go ahead now and plot our 2 points. If they're a fraction, we're going to use the decimal equivalent. So the first one is negative 5, 0. So it's right back here at negative 5, 0. We need another point. We can use either fraction. I think this one would be easier because it's going to be hard to plot a 1/3. A 1/3 is so close to 0, so we're going to use this 5/3 here. And what do we know about 5/3? Well, 5/3, when we take this out to 1 decimal place, I believe that should be 1.7. Let's double check. That's going to, come out to be approximately 1.7. So that means my ordered pair would be 0, comma 1.7, which is about 2. It's closer to 2 than it is to 1, so we're going to kind of go a little bit above what I think is about 1.5. So we're at 0 and about, give or take, 1.5. So I'm going to plot it right about there. That's about the best I can get for that point. Okay, there's 1. And there's 2. It's going to be closer to 2. So we'll put that about right there. And that's going to be at 0, comma 5/3. Now we don't have to plot the other point. We could plot the other point, and it would be right about there, which would be fine. But we don't really need to. We just need 2 points. And that 1/3, again, it's going to be hard to get that 1/3 plotted because it's so close to 0. It's almost at 0. we've got our two different points for the minimum. Connect them together. And there is my line. Okay. We do have a few more questions to look at before we take a break. Come back and start 3-4. So we've got 3-3 to look at, and we've got 3 questions out of 3-3 to go through. These should not take as long to go through as some of the others because they're not graphing, they're algebra based. So we're going to now look at question number 6. We've got 9x plus 3y equals 12, and we have 15x plus 5y equals 23. And so what we want to see if these are parallel, perpendicular, or neither. And how do we do that? Well, we determine whether they are parallel, perpendicular, or neither by taking our equations. We take both of them, we solve them for y, and then we look at our slopes. If the slopes are the same, then they're parallel. If the slopes are opposite or negative reciprocals of each other, so that would be like 5 and a minus a fifth, or 8 and a negative 1/8, those would be perpendicular, okay? Opposite signs flipped over. If they're neither one, then they're just neither. So let's go ahead and take each one of these and solve each one for y. So move the 9x over on our first one. And that leaves me then with 3y equals a minus 9x plus 12. We'll divide by our 3. And you really need to reduce these down as far as you can. That leaves me then with y equals now 9 over 3. Well, 9 over 3 makes it a negative 3x there. 12 divided by 3 is a 4. And what's my slope? The number in front of the x, which in this case is a negative 3. Repeat the process on the other side. Move your 15x over with subtraction. And now we've got 5y equals a minus 15x plus 23. Divide by your 5. And that leaves you with y equals now minus 3x plus 23 over 5. And we know our slope is the same, negative 3. So we moved everything around. We solved it now for the y. And the slope is the number in front of your x value. And so it's negative 3 for both of these. So these lines would then be parallel. If the slopes are the same, what are they? Parallel. So those lines have the same slope. So they are parallel. Okay, so that takes care of that one. We've got 2 more to look at. 12 is next. And what are we going to do for 12? Well, 12, it just says solve the problems for the direction. So 12 says the data regarding the amount spent by a government department is represented in the following graph. Find the change in the amount spent for the time shown in the graph. Is that graph a straight line? Well, it should be, right? Okay, so it's going to be a straight line. So what does that tell you? It tells you it's linear. Okay, when it's a straight line like that, It's a linear line. That means every time you move up and over the same amount. So we need to find the amount changed. So all's happening here is we're increasing all the time. We're never decreasing. So this is government funding, so they always get more money, so they always spend more money. Now, if we want to find our slope, and that's going to be the change in the amount spent, we now need to find 2 points. So we're going to try to come up with the 2 easiest points to look at here and to work with. Does not matter. We've got 4 of them listed. Does not matter which 2 we pick. We just need to find an easy one. When I work this one out, I'm going to let X equal the year. Y is going to be the amount spent. So X is going to be the year. Y is the amount spent. So our ordered pairs are going to be year, comma, amount. So let's go back and look at our graph here. We need 2 points. Now, it does not matter which 2 we pick. We just need to pick 2 of them. So I'm going to start here. I think this one's pretty easy to look at. So let's first off figure out where this Y part is at. So let's try to see how these labels and units are done. Okay, so I'm up at 8. There's 1, 2, 3, 4. Okay, so it looks like this is 8, 8.2, 8.4, 8.6, and 8.8, right? It's going 0.2 every time. So this one is at 1997, and there would be 7. Okay, so right there would be 7. And then the next one up is 7.2. It's kind of in between. So it looks like that first point would be 1997, comma, about 7.1. Right? Because that's about where it's at. There's 7, and there's 7.2. So it's kind of in between them. So we're going to say it's at 7.1. Now, what about the next one? We need another point. It does not matter which one we pick. We can pick any of them. So let's try to pick another easy one. Okay, it looks like I'm going to pick 1999. So let's see what our value would be at 1999. If I look at 1999, and I go over here, okay, there's 8, there's 8.2, there's 8.4. It's kind of in between them, so I would say it's about at 8.3. And I could have used any of these points I would have wanted. But you just got to kind of figure out where it's at. It's in between. So I'm going to say, okay, this is 8.2, this is 8.4, so that one's at about 8.3. Now, what do we need to find? We need to find our average rate of change. So that's going to be our slope, which is m. And that's y1 minus y2 for x1 minus x2, x1, y1, x2, y2. I'm going to plug in the values, and you can finish it. So this is x1 here, y1. So let's plug in our values. So we've got 7.1 minus 8.3, because the y's go on the top, right? Those go on the top. What about down below? These are our x values down below. So x1 is 1997 minus 1999. And you can finish this one from here. All you need to do to finish it is just subtract and then divide. And that's going to tell you how much increased amount of money spent the government uses every year. So you'll come up with your value, and that's going to now be billions per year. So that's how much extra they spend every year. One more. And then we'll take a short break. Move on to question 18. Take a short break. I am going to take you down to the computer lab before we take a break, though, and have you do your student evaluations. So let's look now at question 18. So for question 18, we want to find the slope of this line. Well, first off, we've got four choices. Is this line going to have a positive, a negative, a zero slope, or an undefined? Well, which one is it? Can someone tell me what they think the slope would be? Positive, negative, zero, undefined. Which one? Positive. Why? Because it's going up from left to right. So that's the first thing I want to identify. That way when I get my answer, I can check my answer and make sure it's right. If I made a sign error, I would catch it. So always look at the graph first and understand that this line is going to have a positive slope. Now I need my 2 points. So let's see what we've got for our points here. Well, we've got one of them right here, and it looks like this one is about at 1, I'd say 1, 0. And what about our next one? Well, the next point is right here, and it looks like it's going to be right on that 3. So that one would be at -3, or sorry, let me write it right here, 0, -3, because it's down 3 units. X is 0, Y is the -3. What are our ordered pairs going to be labeled? Well, they're going to be labeled X1, Y1, and X2, Y2. We're going to use our formula, Y1 minus Y2 over X1 minus X2. And I think you can finish this one from here, because this is just nothing but calculations. And so all you'll need to do is plug in your values, work it out, and get the fraction. And the zeros are going to make it really easy. Just watch out for double negatives. So the next thing I'm going to do is I'm going to go ahead and pass out directions for you so that you can take your student evaluation. Okay, so I'll go ahead and pass out these directions here.